Hello viewers, welcome to Math Tech. I am Amit Sharma. Welcome to the lecture series of Abstract Algebra for CSIR NET, GATE, NBHM, TIFR, MSc Mathematics and IIT-JAM exam. This is part 2 of lecture 7. If you haven't seen the part 1 of lecture 7, please go and see. You can find the link in description box. For rest of the viewers, let's start. Normal subgroup of symmetry group Sn. Question number 1. Find all normal subgroups of S2. We know that S2 has two subgroups which are cyclic, namely H1 equal to identity and H2 equal to S2. Also, S2 is a cyclic group, implies an abelian group, implies all subgroups of S2 are normal. Hence, S2 has two normal subgroups, namely H1 equal to identity, which is trivial normal subgroup, H2 equal to S2, which is improper normal subgroup. Question number 2. Find all normal subgroups of S3. We know that S3 has 6 subgroups, out of which 5 are cyclic and 1 is non-abelian, namely H1 equal to identity, H2 containing the element identity 1, 2, H3 containing the element identity 1, 3, H4 containing the element identity 2, 3, H5 containing the element identity 1, 2, 3, 1, 3, 2, and H6 is equal to S3. Since identity and G are always normal subgroup of G, implies H1 equal to identity, which is trivial, and H6 which is equal to S3 is improper, are normal subgroup of S3. Also, the index of H5 in S3 is 2, implies H5 which is proper is a normal subgroup of S3. Let G equal to 1, 2, 3 belongs to S3 and H equal to 1, 2 belongs to S2. Now, GHG inverse, which can be represented by this, is equal to 2, 3, that does not belongs to H2, implies S2 is not a normal subgroup of S3. Similarly, S3 and H4 are not normal subgroup of S3. Hence, S3 has 3 normal subgroups, namely H1 equal to identity, which is trivial normal subgroup, H5, which is proper normal subgroup, H6, which is equal to S3, is improper normal subgroup. Next is number of normal subgroups of Sn. Number 1, if n is greater than equal to 3 and n is not equal to 4, then Sn has exactly 3 normal subgroups, namely H1 equal to identity, H2 equal to An, and H3 equal to Sn. Number 2, if n equal to 4, then S4 has exactly 4 normal subgroups, namely H1 equal to identity, H2 equal to A4, H3 containing the element identity 1, 2, 3, 4, 1, 3, 2, 4, 1, 4, 2, 3, and H4 equal to S4. Question number 3. This question was asked in IIT-JAM exam in 2015. The number of distinct normal subgroup of S3 is. The number of distinct normal subgroup of S3 is 3. For more detail, see question number 2. Next is normal subgroups of alternating group An. Question number 4. Find all normal subgroups of A2. We know that A2 has only one subgroup which is cyclic, namely H1 equal to A2. Also, A2 is a cyclic group, implies an abelian group, implies all subgroups of A2 are normal. Hence, A2 has one normal subgroup, namely H1 equal to A2, which is improper normal subgroup. Question number 5. Find all normal subgroups of A3. We know that A3 has two subgroups which are cyclic, namely H1 equal to identity and H2 equal to A3. Also, A3 is a cyclic group, implies an abelian group, implies all subgroups of A3 are normal. Hence, A3 has two normal subgroups, namely H1 equal to identity, which is trivial normal subgroup, H2 equal to A3, which is improper normal subgroup. Next is number of normal subgroups of An. Number 1, if n is greater than equal to 3 and n not equal to 4, then An has exactly two normal subgroups, namely H1 equal to identity and H2 equal to An. Number 2, if n is equal to 4, then A4 has exactly three normal subgroups, namely H1 equal to identity, H2 containing the element identity 1, 2, 3, 4, 1, 3, 2, 4, 1, 4, 2, 3, and H3 equal to A4. Question number 6. Show that An is always normal subgroup of Sn for every n. Since index of An in Sn is order of Sn divided by order of An, which is equal to 2, implies An is normal subgroup of Sn for every n. For example, A3 is normal subgroup of S3. Question number 7. This question was asked in NBHM MSc exam in 2006. Let G be a finite group and H be a subgroup of G. Let O of G and O of H denote the order of G and H respectively. Identify which of the following statements are necessarily true. Option A. If order of G by order of H is a prime number, then H is normal in G. Option B. If order of G is equal to 2 times order of H, then H is normal in G. Option C. If there exist normal subgroups A and B of G such that H containing the element AB such that A belongs to A, B belongs to B, then H is normal in G. Let G equal to S3 and H containing the element identity 1, 2, and order of G by order of H is 3, which is a prime number, but H is not normal subgroup of S3. For more detail, see question number 2. Therefore, option A is wrong. Now, order of G equal to 2 times order of H implies order of G by order of H is 2, implies index of H in G is 2, implies H is normal subgroup of G. Therefore, option B is true. Let A and B are two normal subgroups of G. H containing the element AB such that A belongs to A, B belongs to B, implies H is equal to AB. Let AB belongs to H and let G belongs to G. Now G into AB, G inverse is equal to GA, G inverse into G, BG inverse, which is further written as GA G inverse into GB G inverse, which belongs to H, implies H is normal subgroup of G. Therefore, option C is true. Hence, options B and C are true. Next is result. Product of two normal subgroups is again a normal subgroup. Question number 8. This question was asked in GATE exam in 2018. Which one of the following statement is true? Option A. Every group of order 12 has a non-trivial proper normal subgroup. Option B. Some group of order 12 does not have a non-trivial proper normal subgroup. Option C. Every group of order 12 has a subgroup of order 6. Option D. Every group of order 12 has an element of order 12. Let G be a group of order 12, then G is isomorphic to Z12, Z6 cross Z2, D6, A4 and Q6. Let G is isomorphic to A4. We know that A4 doesn't have a subgroup of order 6, implies G doesn't have a subgroup of order 6. Therefore, option C is wrong. Let G is isomorphic to D6. We know that D6 is non-abelian group. implies non-cyclic group, implies G doesn't have an element of order 12. Therefore, option D is wrong. Let G is isomorphic to Z12. We know that Z12 is a cyclic group, implies abelian group, and have non-trivial proper normal subgroup of order 2, 3, 4, and 6. Implies G have non-trivial proper normal subgroup of order 2, 3, 4, and 6. Therefore, option B is wrong and option A is true. Hence, option A is right. Question number 9. This question was asked in CSIR NET exam in June 2011. Consider a group G. Let ZG be its center, that is, ZG containing the element G belongs to G, such that GH equal to HG for all H belongs to G. For N belongs to N, Gn containing the element G1, G2 up to Gn belongs to center of G cross center of G up to cross center of G, such that the product of G1, G2, Gn is identity as a subset of direct product of group G cross G up to cross G n times direct product of group G. Gn is option 1 not necessarily a subgroup, option 2 a subgroup but not necessarily a normal subgroup, option 3 a normal subgroup, option 4 isomorphic Zg cross Zg up to cross Zg n minus 1 times. Let H belongs to Gn implies H is equal to H1 H2 up to Hn, such that the product of H1 H2 Hn is identity. Let K belongs to Gn implies K equal to K1 K2 up to Kn, such that the product of K1 K2 Kn is identity. Now Hk inverse is equal to H1 H2 up to Hn into K1 K2 up to Kn inverse, which is equal to H1 H2 up to Hn into K1 inverse K2 inverse up to Kn inverse belongs to Jn, because the product of H1 H2 Hn and K1 inverse K2 inverse up to Kn inverse is identity. Implies Jn is a subgroup. Implies option 1 is wrong. Let G belongs to G and let H belongs to Gn implies H is equal to H1 H2 up to Hn, such that product of H1 H2 Hn is identity. Now GH G inverse is equal to G H1 H2 up to Hn G inverse, which is equal to G H1 G inverse G H2 G inverse up to G Hn G inverse belongs to Jn, because the product of G H1 G inverse G H2 G inverse up to G Hn G inverse is identity. Implies Jn is a normal subgroup. Implies option 2 is wrong and 3 is right. Hence, option 3 is right. Question number 10. This question was asked in CSIR NET exam in June 2011. Let H is equal to identity 1, 2, 3, 4 and K equal to identity 1, 2, 3, 4, 1, 3, 2, 4, 1, 4, 2, 3 be subgroup of S4, where E denotes the identity element of S4. Then option 1 H and K are normal subgroups of S4. Option 2 H is normal in K and K is normal in A4. Option 3 H is normal in A4 but not normal in S4. Option 4 K is normal in S4 but H is not. We know that S4 has 4 normal subgroups, namely H1 equal to identity, H2 equal to A4, H3 containing the element identity 1, 2, 3, 4, 1, 3, 2, 4, 1, 4, 2, 3 and H4 equal to S4. Implies H is not normal subgroup of S4 and K is normal subgroup of S4. Implies option 1 is wrong and option 4 is right. We know that A4 has exactly 3 normal subgroups, namely H1 equal to identity, H2 containing the element identity 1, 2, 3, 4, 1, 3, 2, 4, 1, 4, 2, 3 and H3 equal to A4. Implies H is not normal subgroup of A4 and K is normal subgroup of A4. Implies option 3 is wrong. Now index of h in K is equal to order of K by order of h, which is equal to 2, implies h is normal in K. Therefore option 2 is right. Hence options 2 and 4 are true. Next is normal subgroup of dihedral group Dn. Question number 11. Find all normal subgroups of D2. We know that D2 has 5 subgroups, out of which 4 are cyclic and 1 is abelian, namely H1 equal to R0, S2 containing the element R0 R180, S3 containing the element R0 H, H4 containing the element R0 V, and H5 equal to D2. Also D2 is an abelian group, implies all subgroups of D2 are normal. Hence D2 has 5 normal subgroups, namely H1, which is equal to R0, which is a trivial normal subgroup, H2, H3 and H4, which are proper normal subgroup, H5, which is equal to D2, is improper normal subgroup. Question number 12. Find all normal subgroups of D3. We know that D3 is isomorphic to S3, implies D3 has 3 normal subgroups, namely H1, which is equal to R0, which is a trivial normal subgroup, H2 containing the element R0, R120, R240, which is proper normal subgroup, and H3 equal to D3, which is improper normal subgroup. Question number 13. Find all the normal subgroups of D4. We know that D4 has 10 subgroups, out of which 7 are cyclic, 2 are abelian, and 1 is non-abelian, namely H1 containing the element R0, H2 containing the element R0 R180, H3 containing the element R0 H, H4 containing the element R0 V, H5 containing the element R0 D, H6 containing the element R0 D dash, H7 containing the element R0 R90 R180 R270, H5 containing the element R0 R180 HV, H9 containing the element R0 R180 D and D dash, and H10 equal to D4. Since identity and G are always normal subgroup of G, implies H1, which is equal to R0, which is a trivial, and H10 equal to D4, which is improper, are normal subgroup of D4. Also H2, which is equal to center of D4, implies H2 containing the element R0 R180, which is proper normal subgroup of D4. The index of H7, H8 and H9 in Dn is 2, implies H7, H8, H9, which are proper normal subgroup of D4. Let G equal to R90 belongs to D4 and H is equal to V belongs to H4. Now GH G inverse is equal to R90 V R90 inverse, which is equal to R90 V R270, which is equal to H that does not belongs to H4, implies H4 is not a normal subgroup of D4. Similarly, H3, H5 and H6 are not normal subgroups of D4. Hence, D4 has 6 normal subgroups, namely H1, which is trivial, H2, H7, H8, H9, which is proper, and H10, which is equal to D4, which is improper normal subgroup. Next is number of normal subgroups of Dn. The number of normal subgroups of Dn is equal to tau of n plus 3 if n is even, tau of n plus 1 if n is odd, where tau is known as number of positive divisor of n. Example number 1. The number of normal subgroup of D9 is tau of 9 plus 1, which is equal to 4. Example number 2. The number of normal subgroup of D10 is tau 10 plus 3, which is equal to 7. Example number 3. The number of normal subgroup of D20, which is equal to tau 20 plus 3, which is equal to 9. Question number 14. This question was asked in NBHM MSc exam in 2015. For real numbers a and b, define the mapping tau ab from R to R by tau of ABX is equal to AX plus B. Let G containing the element tau of AB such that A comma B belongs to R, A is not equal to 0. Under composition of mapping, this become a group. Which of the following subgroups of G are normal? Option A, H containing the element tau of AB such that A is not equal to 0, A belongs to Q, B belongs to R. Option B, H containing the element tau 1 comma B such that B belongs to R. Option C, H containing the element tau 1 comma B such that B belongs to Q. Let G containing the element tau AB such that A comma B belongs to R, A is not equal to 0. Let H containing the element tau AB such that A is not equal to 0, A belongs to Q, B belongs to R. Now, tau AB, tau AB, tau AB inverse is represented by this, which is further represented by this, which is equal to AX plus B, which is equal to tau ABX, which implies tau AB, tau AB, tau AB inverse belongs to H, implies H is normal subgroup of G. Therefore, option A is true. Let H containing the element tau 1 comma B such that B belongs to R. Now, tau of AB, tau 1 comma B, tau of A comma B inverse into X is represented by this, which is further represented by this, which is equal to X plus AB belongs to H, which implies tau A comma B, tau 1 comma B, tau A comma B inverse belongs to H, implies H is normal subgroup of G. Therefore, option B is true and option C is wrong. Hence, options A and B are true. Next is normalizer. Let G be a group and let H be subgroup of G. Then normalizer of H is denoted by NH and is defined as NH containing the element X belongs to G such that X inverse is equal to H. Result: the normalizer NH of a subgroup of G is a subgroup of G. Question number 15. Find the normalizer of subgroup identity 1, 2 of S3. S3 containing the element identity 1, 2, 1, 3, 2, 3, 1, 2, 3, 1, 3, 2. Let H containing the element identity 1, 2. Normalizer of H is equal to X belongs to G such that X inverse is equal to H. Since normalizer of H is a subgroup, implies I belongs to NH. Now, the product of 1, 2 H and 1, 2 inverse is equal to identity and 1, 2, which is equal to H, implies 1, 2 belongs to NH. Product of 1, 3 H and 1, 3 inverse is equal to identity and 2, 3, that does not equal to H, implies 1, 3 does not belongs to NH. The product of 2, 3 H and 2, 3 inverse is equal to identity 1, 3, 2, that does not belongs to H, implies 2, 3 does not belongs to NH. The product of 1, 2, 3 H and 1, 2, 3 inverse is equal to identity and 2, 3, that does not equal to H, implies 1, 2, 3 does not belongs to NH. Since 1, 2, 3 does not belongs to NH, implies 1, 3, 2 does not belongs to NH because NH is a subgroup. Therefore, the normalizer of H is identity and 1, 2. Question number 16. This question was asked in NBHM PhD exam in 2018. Let G be a group. Which of the following statements are true? Option A. The NH of a subgroup of G is normal subgroup of G. Option B. The center of G is normal subgroup of G. Option C. If H is normal subgroup of G and is of order 2, then H is contained in center of G. We know that center of G is normal subgroup of G, implies option B is true. Also, we know that normal subgroup of order 2 is contained in center of G, implies option C is true. Let G equal to S3 and H containing the element identity 1, 2 is a subgroup of S3. Now, the normalizer of H is H. For more details, see question number 15. But we know that H containing the element identity 1, 2 is not a normal subgroup of H3. For more details, see question number 2. Implies the normalizer of H is not a normal subgroup of G. Therefore, option A is wrong. Hence, options B and C are right. Question number 17. Let H and K are subgroup of group G. If H is contained in K, K is contained in G, and H is normal subgroup of G, then H is normal subgroup of K. Since H is normal subgroup of G, implies X, H, X inverse belongs to H, for all X belongs to G, and H belongs to H. Let X belongs to K, then X belongs to G, because K is contained in G. Now X belongs to K, H belongs to H, and X, H, X inverse belongs to H, for all X belongs to K, and H belongs to H, implies H is normal subgroup of K. Thank you very much for watching my video. If you like the content, please do like, share and subscribe my channel. If you have any query, comment to me. Thank you very much.